Good morning everyone and welcome to my YouTube channel. So here today we are just going to be looking at a physics problem. It says that cars A and B are traveling in adjacent lanes along a straight road as shown in the figure below. At time t is equal to 0, their positions and speeds are as shown in the diagram. If car A has a constant acceleration of 0.6 and car B has a constant acceleration of 0.46 meters per second, determine when A will overtake B. So how do we calculate this? So firstly, you need to understand one thing. So both of them are going in the same direction. So the point at which car A will overtake car B is firstly they have to be at the same position. Now what does this mean? So let's say the point where these two cars meet, it's this point. Let's say from here up to here, it is just 10 meters. Now car B, from here up to here, it will have to travel 10 meters. But let's look at car A. Car A has to travel first an additional, we have 30 meters here. It has to travel 30 meters. At the same time, it has to go again and add 10 meters. So in total, it will travel 40 meters. So that's why when we are looking at the displacement that car A has to move, we have to account for the distance that it is behind, the 10 meters or the 30 meters. So it means to say the displacement of car A, we have to add a 30 to account for the additional distance which car A has to travel. Now for some of you, the confusion is, you may ask yourself to say, now does it mean that car B is just stationary for us to add this additional 30? Now let me create a picture so that you can understand. So let's look at our car A and our car B like that. So both of them are moving, but you will find that car A is moving faster as in comparison to car B until it catches up with our car B like that. So this is how it works. So it will work in that way. So same approach. So it does not necessarily mean to say when we add our 30 meters, it doesn't mean that car B is stationary. No, it actually means to say car A has to move faster than car B in that sense. So now we have the kinematic equations that we are going to be using. We have v squared should be equal to u squared plus our 2as. We have our s should be equal to ut plus our half at squared. Then we also have our v should be equal to u plus our at. So we do not know the final speed at the point where it will reach the other car. We don't also then know the time. So also this one, we want time, and this formula doesn't have time. Therefore, we are going to use this formula. So now let's integrate this formula to calculate what we want. So what we are going to have is this. Firstly, we have our UB is equal to that. So let's use the formula that we have talked about. So let's begin with our SA. So SA is this one. So now the point at which car A overtakes car B, it means to say they have to be at the same position like that. So that means to say we are going to add a 30 to car A so that it covers this separating distance first. Should be equal to, we have our UAT, we have UT plus half AT squared like that. So the velocity of car A is equal to, we have a 13, so we have 13t plus half. Our acceleration is equal to a 0.6, so we are going to put 0.6. Then we have times our time squared like that. We have our SA plus our 30 should be equal to that. We are going to have our SA plus our 30 should be equal to our 13t. Half times 0.6 will give us a 0.3 t squared like that. Then we are going to have a value. So let's take the 30 the other side. So our SA should be equal to 13t. Then we have plus our 0.3 t squared. then we have minus our 30. So this is our equation number 1, like that. Let's look at this other one. We have anchor B has a constant deceleration of 0.46. So deceleration is the rate of slowing down, therefore this value will attract a negative. So let's begin. So our SB, on the other hand, you shall not add a 30, but it's just SB should be equal to our UT. Now it's the velocity of car B, UT plus our half AT squared. Now let me emphasize on something. So this 30, you don't add the 30 here to say, we don't say SA should be equal to, let's say, UT plus half AT squared plus our 30, since it like the separating distance is 30. We don't add the 30 here. In the actual sense, if you add the 30 here, it means to say you are subtracting. This means to say when you take it this side, it will be your SA minus 30. So you always add the 30 this side. So take note of that, just in case you're doing a similar calculation. So we are going to have our SB should be equal to our UB. Our velocity of B is equal to 20, according to what we have been given, 20t. Then we have plus half. Then our A is equal to the acceleration. Now it's deceleration, meaning it will attract a negative 0.46. Then we have times our time squared, like that. So we are going to have our SB should be equal to 20. Half times negative 0.46. This will give us a negative 0.23 t squared, like that. So now we have the second equation, like that. So this is our equation number 2. Let's put the equations together. So now we have 2 sets of equations. So how are we going to use these equations? So let's identify one thing that is clear. So firstly, if we have 2 cars, at the point where the 2, car A and car B, you can tell to say this is the same displacement. So they have equal displacement at this point. It means to say they are equal. So you can equate your S, the displacement of B and the displacement of A, at the point where car A more like overtakes car B, like that. So we are going to say at the point where they intersect, at the point where car A overtakes car B, they are equal. So at that point, the displacement happens to be equal, like that. So now we are going to equate them. So our SA should be equal to our SB, like that. So taking our SA is equal to 20 minus our 0.23 t squared, equate it to our SA is equal to, so I've done the opposite. So our SA is equal to 13t plus our 0.3 t squared minus our 30 should be equal to our SB is equal to 20t, not just 20t should be minus 0.23 t squared, like that. So we can solve this equation simultaneously. So we are going to have, let's just rearrange this. So we have 0.3 t squared plus our 13t minus 30 should be equal to, we have 20t minus our 0.23 t squared. So let's take this value the other side. It will be a 0.3 t squared. We have plus 0.23 t squared, like that. Then we have plus our 13t. Then we take this value this side, it will be minus 20t. Then we have minus our 30, like that, should be equal to 0, like that. So what we are going to have is 0.3 plus 0.23. This will give us a 0.53, like that. We have t squared, like that. 13 minus 20, this will give us a negative 7t. Then we have minus 30 should be equal to 0 like that. So looking at that, we are going now to use the quadratic formula. So t should be equal to negative p plus or minus the square root of p squared minus our 4ac over our 2a. So in a quadratic equation, this is our a, this is our b, this is our c. So we are going to have our t should be equal to negative, our b is equal to negative 7 like that, plus or minus the square root of our b squared is negative 7 squared like that, minus our 4, our a is equal to 0.53, then our c is equal to a negative 30. Then we divide over our 2, our a value is equal to 0.53 like that. So our t should be equal to negative by negative, it will give us positive 7 plus or minus the square root of negative 7 squared will give us 49. Negative 30 is negative as well. As we can see, 30 is negative. So when we multiply negative by negative, this will give us a positive. So let's multiply 4 by 0.53 by 30. This will give us a value that is equivalent to 63.6 like that. Then we divide by 2 by 0.53. This will give us a value of 1.06 like that. So our time should be equal to 7 plus or minus the root of, when we add our 49 plus our 63.6, this will give us a value of 112.6 like that. Then we divide over our 1.06. Then we are going to have our time should be equal to 7 plus or minus the square root of 112 will give us a value of 10.611 like that. Then we divide over 1.06. So our time will be equal to 7 plus 10.611 over 1.06, or our time shall be equal to a 7 minus 10.611 over, we have a 1.06. So when we do this, we are going to get a value of, when we divide, when we divide this throughout, just the final answer, 7 plus 10.611, we are going to get a value of, divided by 1.06, this will give us a value equivalent to 16.61 seconds. Then here on the other hand, we have our t should be equal to, so we have 7 minus our 10.611, which is giving us a value of negative 3.66 divided by 1.06. This will give us a value equivalent to a negative 3.41 seconds. So the time that is negative shall be ignored. Therefore, the time it will take is 16.61 seconds, like that. Let's look at our next example. It says that a car starts from rest at a constant acceleration of 2 meters per second squared. At the same instant, a truck traveling with a constant speed of 10 meters per second overtakes and passes the car. Then we are told how far beyond the starting point will the car overtake the truck. So here there is a mistake. So it's supposed to be the car overtaking the truck, not the truck overtaking the car. So this is how it's supposed to be. So now these questions can be solved together interchangeably. So the second part says, after what time will the car, after how much time will this happen? So to answer this question, using the same formula, we are looking at time. So we are going to use our same formula. So let's begin with our S of our car should be equal to UT, U of the car plus half AT squared, like that. So to find our S of our So the car starts at rest, meaning to say it's starting at 0 in terms of velocity, times our t should plus our half. Our acceleration is equal to a 2 according to what we have been given. Then we have our time squared like that. So this 2 and this 2 cancels. Here it's 0. So our displacement should be equal to, we are remaining with a half by that. So we are just going to remain with c. SC is equal to t squared like that. Then we look at the other equation and see what it will give us. So the track, it shall be equal to ut plus our half at squared. Now it says that it is traveling at constant speed. When the speed is constant, the acceleration is equal to 0. So we have our st should be equal to ut plus half, then we have 0 by t squared. So all of this will become a 0. So we have our st, which is the displacement of the track, should be equal to just a ut, because we have a plus 0 there, which can be ignored. So this is what we have. So now, one thing that we need to know is, so we have our st should be equal to, it was traveling with a constant speed of 10 meters per second. So we can put a 10t like that. Then one thing that we know is that at the point where the car overtakes the track, their displacements are equal. They are at the same position like that. They are at the same position in the same line. So meaning to say their displacement, which is the position, is the same. So we can equate them to say SC should be equal to ST like that. So this will give us a value. So our SC is known to be equal to, SC is equal to t squared, should be equal to, we have 10t like that. Then we take that the 10 this side, it will be t squared minus our 10t should be equal to 0. Factorize, t is common, we are remaining with a t minus 10 should be equal to 0. So t is equal to 0. This means at the start. So at the start of the journey, t is equal to 0. But the one we are looking for is t minus 10 seconds should be equal to 0. We take the 10 this side. So the time taken will be equal to 10 seconds like that. So it takes 10 seconds. So we have answered after what time. So we have answered after what time will this happen. Then we are asked how far beyond the starting point will the car overtake the track. So to find the position we are going to use this formula. So we have how far, meaning distance. So we have our SC should be equal to t squared. This will be equal to SC should be equal to, we have our time, which is a 10 squared like that. So this will be equal to our 100 meters like that. So this is our SC like that. So it will move 100 meters like that. Then when we look at our last part of the problem, it says, at that instant, what will be the speed of the car? So to find the speed of the car, we know that, so we have v squared should be equal to u squared plus 2as. So we can use this formula if we want, or we can use a simple one, v is equal to u plus our at, because we know everything. We have our s, we have our a, we can use this formula, but for the sake of simplicity, let's use this formula. So we have a v should be equal to u plus our at. Now for the car, it's starting at rest, meaning this constant is 0. So our v of the car at the instant it overtakes the track should be equal to, we have a 0 plus our acceleration is 2 meters per second squared. We have times our time, it takes 10 seconds like that. We are going to multiply them and we are going to get a value that is equivalent to a 20 meters per second as the velocity at which it overtakes the track like that. So that is how you go about that question. Thank you very much for watching. Hope you would like, subscribe, and share for more. Don't forget to like so that my video can reach a broader audience. Comment if there is anything that you need. See you in the next tutorial.